Hi everyone. Tonight's video starts our introduction to real-world questions that will involve the quadratic formula. So these past couple days we have been refreshing our Algebra 1 skills of using the quadratic formula. So we are ready to start looking at how that mathematics is used in the real world. So let's get right into our notes. The title here is Objects with Velocity in the Real World. And it starts off by reminding us of what we had done last week. So last week we had focused on objects that were falling, and this was our model for objects that were falling or dropped. For an object that is launched or thrown, so these are our key words. If something is launched or thrown, which means it has velocity, we need to add this extra term. And just like before, when it was h with the little zero, that was h naught, we're going to call this v naught. And that needs to be added to our model to account for the object's initial vertical velocity. So initial means start, the starting velocity. Vertical means that it's going up. Going to put little words here. So where it starts, or excuse me, how it starts, it's initial and vertical going up. Because an object that's being launched or thrown is going up. So here we can compare the two. This was last week. That's now our prior knowledge. This is new. If you have a highlighter, it would be fantastic to highlight this new model to make it stand out. And a lot of what's here we actually are already very familiar with, because the only new piece is what's in the middle. Everything else is the same. So just like with our dropped or falling objects, h of t will represent current height. Current height. And this will always come from the question. So remember, if it said ground, that equaled 0, or if it was like a cushion at 50 feet, that would equal 50. We would set it equal to 50. So h of t always comes from the question being asked. T is still time. What's h naught? H naught is our initial height. And then we've got our new guy here, v naught, which is going to be our initial velocity. And a hint here is, when reading, look for the word velocity. It will be there. And then you'll know that that's what goes for v naught. And I have a little space, so I'll be more clear up here. Current height comes from question being asked. There are three possibilities for vertical velocity. If the object is launched upward, as we can see right here, that football started on the ground and is going up, the initial vertical velocity is positive. Velocity greater than 0. If the object is launched downward, you see here the volleyball is getting spiked downwards by that player. The initial vertical velocity is negative. And the third possibility, which we will not look at too often, in the next couple days, but it's still important to realize it exists. If the object is launched parallel to the ground, its initial vertical velocity is 0. So we see this baseball player is about to pitch this ball, and it's going to go, that ball will travel parallel. It will eventually, now don't confuse this with the motion, because eventually the motion of the baseball will go down, but we're not talking about the height of the ball, we're talking the velocity. So the velocity, how he's releasing it, it will be parallel to the ground. This velocity is downward, so that's why it's negative. This velocity is upward, so it's positive. So we're talking velocity here, not height. Very good. Let's get right into a practice question. A basketball player passes the ball to a teammate who catches it 11 feet above the court, just above the rim of the basket, and slam dunks it through the hoop. This play is called an alley-oop. The first player releases the ball 5 feet above the court with an initial vertical velocity of 21 feet per second. How long is the ball in the air before being caught, assuming it is caught as it rises? Now, that's a lot of information. And as always, we're going to look for a way to kind of break this down into a set of steps or a procedure, a general procedure that we can apply to any real-world question. So first off, as soon as I see the word velocity, I know that I'm going to be needing to use the quadratic formula. So maybe up here to the side, I write QF for myself. And before I write it, go ahead and try writing the quadratic formula on your own and see if you remember what it is. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. And again, I wrote that because I saw the word velocity when I was reading. As soon as you see velocity, we know we're using quadratic formula. Now that we have that off to the side for ourselves, let's get kind of a menu of values. So I know I'm going to be looking for something that the question tells me. That's going to be h of t. We're going to have velocity, and we're going to have initial height. So reread and see what you can identify, and then we'll see if we match. And don't take up too much space writing this list, because we're going to be using all of this space. So if I look at the question, it says, how long is the ball in the air before being caught? So I need to go read. Can you find out for me, please, where is this ball being caught? Reread for information. Where is it being caught? So here's the player, right? He's about to catch it on its way up. Another player has launched it upwards for him to catch and then slam into the basket. So at what height is he catching it? When I read here, it says basketball player passes the ball to a teammate who catches it 11 feet above the ground. So let's make a note. Asked about when ball caught. So that means our h of t value comes right from this, 11 feet. So I know h of t is 11. Velocity is going to be the easiest value to get right every single time because you're literally going to look for the word velocity. So reread for information, find me that word velocity. And I'm hoping we all see it right here. Velocity, so V naught, is 21. And the very last piece of information I need is my initial height. So at what height was the ball released? Where did the ball start from? Reading for information, the first player releases the ball at 5 feet. So I know my initial height is 5. This is what I need to build my model. So let's write the general model first. H of t equals negative 16t squared plus v naught t plus h naught. Now let's fill it in. So I know h of t is 11 because that came from the question. Negative 16t squared stays. Velocity is 21, so now I've got 21t plus 5. A side note about writing a t, make sure you put a little tail on the end, otherwise that'll look like 2 plus signs side by side, and that could be confusing. To solve this, now check out what we've got. We have a middle term, which means we cannot solve by square roots. So it's a good thing we have been practicing our quadratic formula skills because we're about to use it. But before we do that, what's wrong with that? Why can't I just say A is negative 16, B is 21, and C is 5? Because from our refresher couple of days, we know that this has to be set equal to 0 before we can do that. So we're going to need to move that negative 11 out of there by subtracting it, and we get 0 equals negative 16t squared plus 21t. And then what's 5 minus 11? By the way, you definitely are going to need your calculator, so if you haven't gotten your calculator out yet, go ahead and get it out, press pause, and go ahead and do 5 minus 11, and we should get negative 6. Now I can identify A, B, C. I'm actually going to change colors here just for the notes because we're about to get into the quadratic formula. So A is negative 16 because that's what's next to the squared term. B is always what's next to x, or in this case t. So my middle term here, plus 21. You don't need to write the plus, just 21. And then last but not least, C is my constant term, which is negative 6. I already up here jotted down the quadratic formula for myself, so I'd ask that you press pause, please, and you actually try finishing this. Now, when you're working, like let's say I start working right here, I'm going to put a line down my equal sign, keeping it nice and neat. Now, if I run out of space, I can just set up a new equal sign and keep the line going somewhere else in my blank space. So that's a nice way to kind of organize your work. So please press pause using the quadratic formula, A, B, and C right here, and set it up. Just do the setup. Following the model at the top, it's going to be negative b. So that's going to be negative 21 plus or minus the square root of b squared, so 21 squared, minus 4 times negative 16, 4a, times negative 6, which is c. All divided by 2a. From what I've seen in class, my one word of caution here is to really make sure that that division bar is going all the way across. Some people by accident, I'm just going to put it in a different color, are kind of like only drawing their division bar that far, and then suddenly the whole division is happening under the radical, which is incorrect. Don't do that. So just this here is underneath the square root sign, and all of this numerator is being divided by here. The other thing is to make sure that we keep the fraction together. So on my next step, I'm going to have a whole new fraction. Negative 21 is going to stay, plus or minus the square root, 21 squared. Go ahead and use your calculator, find 21 squared. We should be getting, in your calculator first, go do it, 21 squared is 441. Now let's first on our own decide what the sign is going to be. So negative times a negative is a positive, times a negative is a negative. Now in my calculator I can just worry about doing 4 times 16 times 6. 4 times 16 times 6. And we should be getting 384. All divided by negative 32. Next step. So again, look, as I go from step to step, I have a new fraction. So negative 21 plus or minus. Now I can do this subtraction in my calculator. Put my square root sign to get ready. So 441 minus 384 equals 57, still under the square root because we have not taken the square root yet, all divided by negative 32. 57 is definitely not a perfect square because if I remember my list of perfect squares, it goes 49, that's 7 squared, and 8 squared is 64. So that means that I'm going to get a decimal, and that's fine. That's not a problem. For me, instead of continuing this line, so depending on how big you've written will determine what you do next, I'm going to choose to let my equal sign go here. But that's okay, as long as it makes a fluid path that you could show this paper to anybody and they would be able to follow your work, we're good to go. So that's negative 21 plus or minus. In my calculator, I'm going to do the square root of 57. It will be a decimal. So take a second and please do the square root of 57. You will get a decimal. Square root of 57 comes out to be 7.5498. So we're going to round that to 5. All divided by negative 32. Notice, all divided by. So all of this is in the top. All divided by negative 32. After I've taken the square root, there's nothing else for me to do in terms of simplifying. So now I can break this up. It's going to be negative 21 plus 7.55, all divided by negative 32, and negative 21 minus 7.55, all divided by negative 32. I'd ask that you pause the video and finish getting your two answers, and then we'll see if we match. Press pause and see what you get. So when I do negative 21 plus 7.55, I got negative 13.45, and I'm dividing that by negative 32. Negative divided by a negative is a positive. In dividing that by 32, I got 0.42. Now here, negative 21 minus 7.55 got me negative 28.55, all divided by negative 32. Once again, negative divided by negative is a positive, and then 28.55 divided by 32 is 0.892. So let's go back and reread the question we were asked. It says, how long is the ball in the air before being caught? Assuming it's caught as it rises. So remember, this ball is going to be going up, and it's going to pass that height, and then it's going to be going down. So there's 2 moments in time that it's going to be at that 11-foot height. That's going to be 0.42 seconds, and again at 0.89 seconds as it comes back down. So if we're strictly talking about, let's see if I can move this without moving the whole thing. Nope. Oh, that's not bad. I want to give myself a little more space here. So if we're being strictly asked for when is it on its way up, which of these 2 answers will I keep? Well, from my picture I see this is on the way up, this is on the way down. So this is my answer for when it's on the way up. I will, in terms of answering the real question, ignore the second answer. So it's at 0.42 seconds. So roughly a little less than half a second before it's caught. Let's work on number 2, the setup for number 2, and then we'll stop our flip notes for tonight. A man tosses a penny up into the air above a 100-foot deep well with a velocity of 5 feet per second. The penny leaves the man's hand at a height of 4 feet. How long will it take the penny to reach the bottom of the well? As soon as I see the word velocity, I'm going to set up the following list of variables. As soon as I see this word velocity, I'm going to set up this list because I know I'm going to be working on completing this general model. So as I say it, if you didn't write it down yet, please write it. H of t equals negative 16t squared plus v naught t plus h naught. Velocity, I would say, is probably the easiest one to knock out. So read for information and what's the velocity. I'm hoping our attention is drawn right here where it says velocity of 5 feet, initial velocity of 5 feet per second. So my velocity is 5. Now we have two different heights and we have to keep them straight. So remember, h of t is from the question. H naught is initial height. So please reread for information and look for either the initial height or what's the question asking. And you could be like, Ms. J, I'm really still not sure. And I'd be like, okay, no problem. Let's draw a picture. So let's draw a picture. Here's the well. Imagine I'm going to draw the well over here. And that's the top of the well. So I've got my well, and a very high-tech well going on here. And it says that he tosses a penny up into the air above a 100-foot deep well. So that means that from the top of the well to the bottom of the well, if you want to actually finish this 3D drawing, if you extend these two vertical lines and then kind of do like a curved line, here's your 3D well. I know from the top of the well to the bottom of the well is how deep? Well, it told me, 100 feet. And it says that the penny leaves the man's hand at a height of 4 feet. So remember, this is the ground. This well is beneath the ground. So here's a guy. Draw a guy. Very high-tech again. Definitely not to size. This would be like a pool, but anyway. So he's dropping this penny into the well, and it's at a height of 4 feet. So it leaves the man's hand at 4 feet. That's going to be my initial height. Now, it's done traveling. It says, how long will it take for the penny to reach the bottom of the well? So, what do I put for this number? How do I deal with the fact that this well is below ground? Because if I put 100, think about that. If I put a positive 100 right here, I'm saying the penny is way up here in the air, 100 feet above ground. So to say below ground, we're going to say negative 100. So it's come up in classes, is this number ever negative? And here's our first example of where it is negative, below ground. So below ground, or if I was dealing with a negative temperature, maybe. Yes, so negative 100. Now we're ready to fill in our model. So h of t is negative 100 equals negative 16t squared plus my velocity is 5. T, remember to put a little tail on the t, plus 4. Can I do the quadratic formula as this is written? I'm hoping you're saying no, 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 because, check it out, we need this to be equal to 0. So how am I going to make that happen? Well, I see a negative 100. What's the inverse operation, or the opposite of a negative 100? That would be a positive 100. So we will add 100 to both sides. We get 0 equals negative 16t squared plus 5t plus 104. Now I can say a equals negative 16, b equals 5, and c equals 104. Let me move the ground over a little bit. So, housekeeping, manage your blank space. So what I mean by that, don't do what I'm about to do. Please don't do this right in the middle of the whole space. From the first one we did, we realized we're going to have a couple steps that we need to fit. So if I start right here, I'm going to draw a line down my equal sign and stay true to that line. Get all of your equal signs on the line. I am going to leave the rest of number 2 for you to finish as part of tonight's assignment. The 2 answers that we should get when you're done are negative 2.398 is one of your answers, and 2.71. These are going to be 2 separate answers. The question I'm going to start class with tomorrow is, which one of these do we keep? So I get both these answers. Maybe I should put them in separate boxes. I get this as an answer, and I get this as an answer. So the question, do you keep both? Is what we will start class with tomorrow. So any questions on this one? If you're not able to get these 2 answers, please let me know. Remember, either keep your equal signs kind of lined up before the breakup there, or if you have more steps to show, you can always start a new, you don't need to write X, you can start a new line of work if need be. All right? Nice job on these notes, folks, and if you have questions, again, please reach out on Remind. Looking forward to seeing how we do with the quadratic formula on wrapping up number 2. Hoping we get these 2 answers, and please be ready for that question at the start of class. Do you keep both of these answers? Why or why not? Have a great night, everybody.